So anyway, I wanted to talk about the multi-filter in the context of an audio source rather than just an audio processor. So the first thing I wanted to mention is that state variable filters, just by the nature of their design, they have quadrature output relationships. So the multi-filter is self-oscillating right now, obviously, and we're looking at low pass on the green trace, band pass on the blue trace, and high pass on the red trace. And you can see that relative to both low pass and high pass, the band pass output has a quadrature relationship, or 90 degrees out of phase. And these relationships hold true even when you do things like feedback patching, which I'll show you. So we're just going to patch some feedback back into the FM input for now. And we're going to use the variable output set to low pass mode, panned all the way over here to low pass to give us some low pass feedback. So I'll patch that into the FM input. And what you can see is that when set dead center, of course, we get the sine waves. But as I crank it over to clockwise, the non-inverted side, you see that the band pass begins to take on a ramp shape, and the low pass and high pass both take on a logarithmic and exponential shape, respectively. So that's pretty interesting. And also note that it changes the pitch quite a bit. So if you want to use this as more of a modulation source, it's with this feedback and then maybe a little bit more CV, it's easy to take the multi-filter down into LFO range. Anyway, so that's kind of interesting. And what's also interesting is if we pan the variable output over to bandpass, those relationships flip. So pan it over there and dial in some more feedback, and now you can see that the high pass and low pass outputs take on complementary ramp shapes, while the band pass takes on the exponential or logarithmic waveform. So that's pretty interesting and pretty useful. And you can go all the way over to high pass, and of course it just inverts that relationship. So that's high pass, band pass, and low pass. In the last video I showed you how the outputs have this quadrature relationship. And so what I'm going to show you now is using the variable output phase modulation. So what we're hearing right now is just a sine wave, and I hope that the microphone is picking that up from my monitors here. And I've got an audio rate modulation source patched into the mode input. And the mode switch in this example is set to bandpass. So what this is going to do is it's going to phase modulate the output plus and minus 90 degrees. In this mode. So it's kind of nice. Of course, this is a triangle wave I'm using as the modulation source. Always sounds better with a sine wave, but I don't have one available in this case right now. So the other thing I wanted to mention is that, okay, so this mode switch here is set to bandpass. That means no modulation, track switch down, knob in the center, that's bandpass mode. If I flip this down, that becomes a notch. And if you know anything about phase relationships of this type of filter, the notch is where high pass and low pass cancel. So as an aside, the most pronounced notch effect that you'll get using the filter is with the resonance all the way down. Personally, myself, I always, if I'm using a notch filter, I like to tilt it to the high pass a little bit and give it a little bit of resonance. It sounds really nice. But anyways, so that's why dialed in the center. And the cancellation isn't perfect either, as you can see. But dialed in the center, the output is quite low. So when we patch our modulation source into the mode CV input, we get a 4-quadrant multiplication of the multifilter's output. So ring modulation. And you can still, use all this with feedback and get variable wave shapes as well. In the last video, I was showing you the phase modulation and amplitude modulation of the variable mode output. The multi-filter is really good at pinging. In fact, it has a dedicated ping input. So what I wanted to add is, using it as like a percussive tone source, as well as using the AM and the PM, is really, really good. So that's the amplitude modulation, the ring modulation. And I'm just pinging it with the other section of the sport modulator that you can't see. Sometimes with this stuff, like less is more. So, but I get really convincing percussive bell tones and other, realistic percussive tones out of this quite a bit. So that's the AM. This is the PM. So that's almost no modulation. See if we can get it to ring out a little longer. There we go. When synthesizing bell tones, often I'll use the FM input as the modulation input for the audio rate modulation, and then I'll use a little bit of LFO in phase modulation mode here to get that just real subtle vibrato. And I don't know, for some reason that combination works really, really well for bell tones. And again, it sounds better with a sine wave as modulation source, but it sounds really good.